When making games, you've likely run into the issue of needing code you've written before in another part of your project, and this could be for level transitions, teleporting the player, creating enemy AI, literally anything. Generally speaking, this is a problem of code reuse. We need to find a way to reuse code without just copy and pasting it. And while there are other solutions to this problem, we generally have two design patterns that are most applicable here, those being composition and inheritance. Between these two patterns, most people would recommend you prefer composition over inheritance, and the rationale behind this is pretty solid. Even though inheritance is a very powerful tool, it can easily make messes in projects when it's applied incorrectly. So that's why in today's video, I want to talk about why you should even use inheritance anyways if composition is so useful. Something else that's really useful is today's sponsor, Brilliant. When making more technical or theoretical videos like this, it's really important to stay educated and up to date on my math and computer science skills, and chances are you have the same goal in mind as well. With Brilliant, you'll be able to learn and review math and science topics in whichever way best suits you, as Brilliant personalizes your learning experience with visual and interactive practice lessons. Learning with Brilliant is extremely rewarding because you'll be made an active participant in the learning process with Brilliant's mix of challenges designed to motivate you, as well as the encouragement to keep you at your learning goals. To learn for free with Brilliant for a full 30 days, go to brilliant.org/retrodead, scan the QR code on screen, or click the link in the description. Brilliant's also given my viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Thanks again to Brilliant, and back to the video. Before getting into inheritance, what is composition and what about it makes it so useful for so many situations? Composition is a design pattern that suggests we create components that encompass a singular set of actions and responsibilities instead of entities that handle various sets of actions and multiple responsibilities. Say you wanted to create an action platformer character. Without composition, all the code for movement, health, and attacking might end up in the same script, or at the very least might be intertwined between multiple scripts. This can have a lot of issues, such as if we want to change something about attacking or movement, we may accidentally mess up something related to health, and vice versa. Instead, with composition, we design all the components to be completely separate units of functionality. We create a character that acts as a container for our components. From there, we can add a component responsible for movement, then attach a health component that knows how we take damage, then some sort of attack component that reacts to player input and does an attack. This way, if we want to change something in one component, we don't really have to worry about breaking something somewhere else. Additionally, if these components are especially modular, we can use them elsewhere, like for enemies. We do also have to consider how each of these components communicate with each other, as that can be a bit tricky depending on what you're doing exactly. But hopefully it's clear to see why composition is so useful. Using components, we're able to solve the code reuse problem while making our code more modular and encapsulated, improving stability, consistency, and maintainability of our code bases. For the most part, inheritance is just as useful as composition, but because of the nature of classes and abstract data types, it's much easier to code yourself into a corner with inheritance. For example, if you have a superclass for entities, these are things like your players, enemies, and then some environmental things like trees and barrels. Then if you add an attack function, suddenly every tree and barrel has the capability to attack. This may not seem like a big deal at first since there are plenty of workarounds for this, such as splitting enemies into combatant and environmental subclasses and only letting combatants have attacks. Of course, you'd have to move your damage variables and attack functions, but that doesn't really require a lot of effort, right? But then you decide to add environmental hazards. Sure, you could make a whole new class, but you already have the environmental subclass, so we can extend this class again. We're in a deal damage function, its own damage variables, and I hope you can see where the issues are beginning with this approach. We've got duplicate variables, duplicate functions, several disjointed child classes with overlapping functionality. Things got really convoluted really fast, and we weren't even trying to solve an especially complex problem. Seeing this, it does become pretty clear why some more experienced developers point newer developers towards composition to solve their problems instead of inheritance. It isn't because inheritance is bad or anything, but because it's really easy to fall back on and use it for problems it wasn't really designed for. Unfortunately, inheritance doesn't really have the versatility of composition either, but it does make up for it for being very useful in a few really important places. In my experience, I've been able to identify about 2 places where inheritance is really useful. First is when we want to model entities, their data, and the interactions between them. If you've made a game that has a good variety of items, weapons, spells, or anything that's extensively data-driven like a simulation, then this is probably the use of inheritance you're most familiar with. You can create a generic class for something, say an item, then make a subclass for that item, such as potions or weapons, and add whatever functionality you'd like to them. We could use other patterns or strategies to represent these items items or any data really, but inheritance has an edge in that it's just really simple and really scalable. In many cases, the code is front-loaded on creating the base class, such as implementing variables and generic behaviors. Then you can add or override features as you see fit. Because of this, we're able to reuse a lot of code between classes. Even though inheritance is perfect for this use case, it's really important to make sure that you actually have a reason to extend a class. Continuing with the item example, you do want to extend classes when you do have exceptionally different functionality, such as the case with weapons and potions, where both would have several unique functions and variables. The other place I found inheritance to be really useful is when we need guaranteed functionality, and we do this using interfaces. For those who don't know, interfaces are classes that really don't have any functional code. Instead, they define their functions, their return types, and sometimes variables and constants, though this does differ quite a bit depending on the language. The use of interfaces isn't really obvious at first, especially when comparing them to standard classes or abstract classes, but there's some additional things to keep in mind about interfaces. When you use an interface, you must implement everything it defines, without exception. Because of this, interfaces are said to be contracts. The act of using your interface is like signing a contract saying you will implement all the functions defined in the interface. However, the interface doesn't really care how you do this, as long as everything is defined and the appropriate types are returned. As programmers, this is great because we'll always have an idea of what to expect with any class using a given interface. So, interfaces are something I use pretty frequently when I need systems I need to be reliable. These are usually things that are accessed often, like libraries, add-ons, or extensions. Back in the dark ages when I still used Godot 3.5, even though 4 had been available for a while, I needed a more flexible system for sound and music in my games, so I wrote a small set of classes to handle this for me. At the core of this was an interface called Audio Request. This class defined the basic behavior I needed for audio so I can implement each feature exactly as I needed them between sound effects and music. An additional advantage of handling my audio like this was that the central audio player could treat any sound effect or music request essentially the same. Because interfaces ensure that all the functionality would work, I ended up with a really stable system and I was confident using this in all my projects. Before wrapping this video up, I wanted to highlight that there's nothing really stopping you from using both of these approaches together. Let's look at a weapon system as a quick example of this. We can start by making a weapon class that will act as both a component other systems can check for, and as an abstract class we can use to add base functionality to. And that base functionality might be something like equip weapon, unequip weapon, and use weapon. Nothing really too crazy going on here. From there, if we wanted to add a new weapon, we can just extend the class and start adding in new behaviors in that extended class. This does bring up a lot of questions though, such as how we would handle melee weapons versus ranged weapons, projectiles versus hit scan, and even things like radial damage for explosives. And I think here is where this approach really shines. You can keep using this approach all the way down. For instance, if we wanted a melee weapon, we can make our extended class have its use weapon method play a swing animation and create a hitbox. Or for ranged weapons that need some sort of ammo, we can create an ammo component that we can attach to these weapons so that we don't have to add extra variables to weapons that don't really need them, such as melee weapons. There are a lot of ways to approach this, none of which are the right or wrong way, but if you limit yourself to just composition or inheritance, you can end up making things harder than they need to be. So hopefully this is a good demonstration of that idea. And that's it. The conversation of composition and inheritance is really never ending, so there's a lot of arguments for and against a lot of what I'm saying here. But I really wanted to give you all a decent foundation on the topic to help inform you when designing the architecture of your games. If there's something you think I missed, want to correct me on something I messed up, or just want to chat about the topic more, feel free to leave a comment or join my Discord server down below. If you enjoyed the video, consider leaving a like, subscribing, or even supporting the channel on Ko-fi. Thanks again for Brilliant for sponsoring the video, and I'll see you in the next one. I also just want to come on here and say thanks for watching the first video of the year. Sorry it took so long to come out again. And also thanks to Derp for supporting the channel once again. It's really appreciated. I really don't have too much to say at the end of this video. Okay, I think that's actually it. Bye guys.